Hello there, welcome back to the new lecture. So in this lecture we are going to discuss about hydraulic calculation for sprinkler system design by using a Light software. So first of all, before start the calculation in software, first we have to classify the occupancies for which spaces you are designing. Okay, so all of you know that NFPA 13, National Fire Protection Association 13, it is the standard for the installation of a sprinkler system, has categorized occupancies into various hazard classification based on the potential fire hazard present. Okay, so generally you can see in this table we have a light hazard occupancies, then ordinary hazard occupancies may be further classified into two groups. Then next we have a extra hazard occupancies. Here you can see some example is written. Actually light hazard occupancy, here what happened? In light hazard, occupancies where the quantity and combustibility of content are low and fire with relatively low rate of heat release are expected. Example include churches, clubs, educational building, hospitals, etc. Then next we have a ordinary hazard. So here the occupancies where the quantity and combustibility of contents are moderate and fire with moderate rate of heat release are expected. Here the example include in group 1, here it is given in group 2. Then finally we have an extra hazard. So here the occupancies where the quantity and combustibility of content are high and fire with high rate of heat release are expected, but where high quantity of water are likely to be effective in controlling the fire. So example include, see, they may be also categorized into group 1, group 2. So suppose we are designing for light hazard occupancy. Okay, here you can see I have taken some example here for which comes under light hazard occupancy as per NFPA. Suppose we are designing for restaurant sitting area, that comes under light hazard occupancies. So here I am writing the hazard classification light hazard. Okay, then if you know the hazard, so as per that you can write down the area coverage by sprinkler. So in case of light hazard occupancy, area one sprinkler coverage area is how much? So you can open the table and see, here you will get each and everything. See, protection area and maximum spacing. So in case of light hazard, maximum protection area by one sprinkler is 225, spacing 50. Okay, if it is non-combustible obstruction and obstructed and combustible obstructed. Okay, so here write down the maximum coverage area by each sprinkler is 225. Okay, then as per NFPA density, you will get from the table only how much density we have to take. So you have to open the density area curve from here. Okay, in case of light hazard, see the density value is given in GPM per square feet, 2.1, and area of sprinkler operation is 1500 square feet, means a remote area in which we have to, because in case of hydraulic calculation only we have to do the hydraulic calculation, only we have to consider that sprinkler which comes under remote area, na? So that I will explain you. So in light hazard, density is 0.1 and area of sprinkler is 1500. Okay, so here I am writing this density value 0.1 and total area protection, same, area of sprinkler operation or remote area 1500 square feet. From the table you will get. Okay, now the next one, K factor. What is K factor here? Why I am filling this all detail? Because our main target, we need to calculate the total number of sprinkler in remote area. Okay, because hydraulic calculation always we have to do, always we have to consider that sprinkler in hydraulic calculation which comes under remote area. Okay, under 1500 square feet, whatever sprinkler are coming, that we have to take in calculation. So K factor is what here? K factor is known as a discharge coefficient. It is a critical parameter used in the design of fire sprinkler system. Okay, it represents the discharge rate of water from a sprinkler head under specific conditions, and it is typically expressed in gallon per minute per square feet of pressure. Okay, so the standard K factor, how much we have to take? A standard K factor of 5.6 is a common value used for many types of sprinkler head, okay, and it is not expensive. So generally we are using 5.6. Here you have to remember one thing, that it is essential to note that the appropriate K factor for a specific sprinkler head depends on its design, intended application, and the requirement of the fire protection system. So different types of sprinkler head may have varying K factor based on factors such as orifice size, deflector shape, and intended coverage area. Okay. So designer must select the correct K factor based on the specific characteristics of the sprinkler head being used and the hydraulic calculation for the sprinkler system. So normally, in normal condition, we are using orifice diameter 1.5 inch if you are using. So for that we are considering 5.6 K factor value, okay, because it is not expensive, and generally in normal condition we are using that only. Same now here, to find out the total number of sprinkler in remote area, see here the formula is apply, means total area, protection area, divide by area coverage by 1 sprinkler. 1500 divided by 225, you will get 6.67. So near about 7 sprinkler. It means in remote area or design area, how many sprinkler will comes? 7 sprinkler. So in drawing you can see here only we have considered the 7 sprinkler during the hydraulic calculation. 1, 2, 3, 4, 5, 6, 7. Okay. So you have to consider the 7 sprinkler and which comes under farthest sprinkler you have to select. On only 7 sprinkler we have to consider during the hydraulic calculation. Okay. So okay, we have got that. So this is our main target, to calculate the total number of sprinkler in remote area. Now if you want to calculate the remote area length, so okay, for that formula is written here, 1.2 protection root of protection area. To find out the remote area width, you have to same this one, total protection area divided by remote area length. So here you will get the remote area width. Now the distance between sprinkler, how much you are taking. So as I told you, you can see here it is written maximum distance. In case of light hazard, how much maximum spacing you have to maintain between sprinkler? 15 feet. So here I am assuming, suppose one distance between two sprinkler is 14 feet. You can see in this drawing also, from 1 to 2 sprinkler, from 1 to 2, see maximum spacing we have considered 14 feet. 14 feet. Okay. So sprinkler to sprinkler we are maintaining, and maximum distance you can go up to 15 feet as per NFPA 13. Now to find out the distance between branch line, again you have to use the formula D5 by D22. D5 means here area coverage by one sprinkler divided by distance between sprinklers. So you will get the distance between branch line 16 feet. You can see in this drawing we have taken from this branch to this branch distance is 16 feet, because in calculation we have got 16 feet. Okay. Now the maximum number of sprinkler per branch. So to calculate that, you have to use this formula, 1.2 root of AP protection area 1500 square feet divided by spacing between sprinkler. So around 3.3 means consider as a 3, okay, or 4, whatever. So you cannot go beyond, it means the maximum number of sprinkler per branch, how many sprinkler you have to consider? 3. So that is why in drawing you can see in each branch we have considered maximum 3 sprinkler only. Okay. Now same if you want to find out the flow rate per sprinkler, so you have to use the formula QS is equal to density into a coverage area by 1 sprinkler. So we have got 22.5 GV. Okay, so flow rate per sprinkler is 22.5. Same way you can calculate the residual pressure also, minimum how much we have to maintain. Residual pressure is the pressure acting at a point in a system when flow being delivered. So to find out the residual pressure, same here I am using this formula, K factor formula, Q is equal to K root P. So P is what? Here residual pressure. So when you put the flow value and K factor value, so you will get around 16.14 psi. And as per NFPA, minimum residual pressure should be 15 psi for light hazard. Okay. And C value you will get based on which type of material you are using. Okay. So material of pipe is what, because this all value now we need during the calculation. That is why I'm just entering material of pipe, black steel pipe. If you're using in table, you can see, just scroll down here as per your types of material. See the C value, Hazen-Williams C value is given. So black steel you are using 120. So write down here 120. Okay. So this thing we have to fill. Now here I am opening the Light software. In that we have to start the, so here you can see I have a Fire Light software 6.00.247 version. Open it. See, now the software will open. Here you will get one message. Would you like to see if an update is available? So if you want to see, so you can hit on yes, otherwise no. Hit on OK. Now the first thing, before starting the calculation, the first thing you have to save this. Okay, we are designing for what? All of you know. We are designing for restaurant sitting area by space. So first now come here in File tab. So from here also you can save or directly see. Here option is given. Save icon is given, I think. Okay. So project, edit, File tab. If you want to open a new project, you have to hit on new. So first now open the new project. Hit on new. And now try to save it. So how to save it? Here save icon is given. First, before writing anything, first you have to save the project. Hit on save. Now where you want to save? Suppose in desktop I want to save with the name restaurant sitting area. Okay, save it. So now the project is saved. You can see here the name is written. Okay, getting? Now right click on this restaurant sitting area, open selected project. Yes. So now see, if you want to open, you can open that project. Otherwise from your project only, because by default the presently we are working in restaurant sitting area only. So come here in project, and first we have to fill general project data, everything. So in project, first you have to hit on first option, general project data. So here you can see in this project data, now we have to fill some data here, like project title is what. So we are designing for restaurant sitting area. So here I am giving the name sitting area. Designed by whom? Designer name. Okay, you have to write down the engineer Sajjad. Date. Okay, then code reference. What code reference you are using? So we are using NFPA 13. We know that NFPA 13, it is the standard for the installation of fire sprinkler. Approving agency, you can write down the name. Okay, anything. So write down the name of approving agency, civil defense. Here you have to write down some comments. So that also, suppose this is my sample project. So I have given the name sample project. Okay. Now come to next step. This is our project data. Here you have to fill the project data. Now here you have to fill the client data. Then company data, company name. Here you have to hit on building name, building data, building name, building owner name. Okay. So these are some non-technical data which you have to fill. Okay. After that, the next tab is what? System tab. You have to come here in system tab, which is very important. So now here we have to start to fill the detail. In that, first see here one option is given, outside hose stream allow in GPM. So if you remember in Excel sheet, I have shown you one table. In that table, see here hose stream demand and water supply duration requirement for hydraulically calculated system is given. For light hazard, total combined inside and outside hose is given 100 GPM. No? So as per that, if you want to fill that detail here, so write down outside hose stream allowance, whatever you want to write, 100 GPM, write down. Okay. Default pipe material, which type of pipe material we are using? If you remember in Excel sheet, I have shown you we are using black steel pipe. So from this drop down list, here see different types of pipe material is giving. Okay, here we have to select the types of pipe material means wet steel pipe you are using. So steel pipe generally we are using and wet system. No? So schedule 40 wet steel pipe I am assuming. Here you will get the different pipe material, but we are using schedule 40 wet steel. Select that automatically. Here you will get the 4 number. Okay, then default K factor value. From here also you can take the K factor value based on orifice size. Okay, orifice type, orifice size, you will get the K factor value. Okay, from here also you can select. Otherwise what you can do, normally as I told you, what we are doing, normal case generally we are using 5.6. okay, just take that value 5.6. Sprinkler model, which type of sprinkler you are using. So quick response sprinkler I am using, so just write down QR. Sprinkler make, write down the manufacturer name. Okay, so suppose Tyco I have written here. Temperature rating, see here you have to write down the temperature rating. So temperature rating 155 degree Fahrenheit suppose. Okay, in normal condition we are using which temperature rating, 55 to 77 degree Celsius. No? So suppose temperature rating of sprinkler 155 degree Fahrenheit. Okay, sprinkler size you can write down 0.5 inches. Okay, then labor rate, don't need to fill this detail. Okay, here only this option, primary type of discharge. So from this list you have to select the sprinkler because we are designing for sprinkler system. Okay, now hazard classification, all of you know from this drop down list, hit on light hazard. Okay, we are designing for light hazard. And minimum desired density, how much we have to take in case of light hazard. When you hit on this drop down list, only you have to select the types of hazard, automatically density you will get. From the design area density curve, if you remember, we have taken same. And sprinkler system type, which type of sprinkler it is, wet sprinkler system, so select the wet. Area of a sprinkler operation, how much? If you remember, I have shown you in Excel sheet, area of a sprinkler operation we have to take for in case of light hazard 1500 square feet. Okay, so just fill this detail, 1500 square feet. And maximum area per sprinkler is what? 225 in case of light hazard. Okay, so these are the detail which we have to fill. After that, just come directly here, test static pressure, test residual pressure, test flow. Actually here we have city water main flow test result which you will get from the NFPA 291. So here municipality people will give you this detail test city water main flow test result. In that test static pressure, test residual pressure, test flow rate is given. Okay, so this detail you will get from the municipality people. Suppose I am assuming here 90, test static, test residual 60 psi, test flow rate suppose 1000 GPM. Okay, here I have written. Now calculated demand pressure, calculated demand flow rate. This is our main target to calculate, and this value you will get from where? It is written. After calculations have been performed, the program will put the total system demand pressure in this field automatically. Okay, so don't need to fill this detail, only we have to fill up to here. Now if you want to save the project, better is to save. Okay, save it from here directly. Now the next thing, now you have to fill the pipe data. So in project only, enter or edit pipe data option is given. Hit on that. Here you can see enter or edit pipe data, pipe 1 to 10. Here in pipe data, just enter the, so I am opening the Excel sheet. You can see in this drawing, we are going to start from here. As I told you, in hydraulic calculation only we have to consider the remote area sprinkler, 7 sprinkler. Okay, which comes farthest from the water source. Okay, so from 1 to 2, path 1 to 2, sprinkler spacing is 14 feet and diameter we have got is 1 inch. Okay, how to find out the diameter? Again, see here I have taken the schedule. See, it is a light hazard occupancy. So in case of light hazard, you have to prefer this table. Steel pipe you are using, so up to 2 sprinkler 1 inch diameter, 3 sprinkler 1/4 inch, 5 sprinkler 1.5 inch. Okay, as per that we have to. So see here, one sprinkler is coming for 1 to 2 parts, so 1 inch diameter. I have taken pipe diameter. So that in this way you have to do, you will get the diameter. Okay, from 1 to 2 part, diameter is 1 inch, 14 feet. From 2 to 3 parts, same, diameter of pipe is 1 inch, spacing 14. So come here, open the X and write down here. Path 1 to 2. Material, which type of material we are using for schedule 40, if you remember. Okay, schedule 40 we are using. So 4 number is written. Okay. If you are select any other types of a copper tube, you can select this 2 number. If you want to use some other type like schedule 40 wet steel, select the 4 number. Okay. Now here in the first column you have to write down the diameter in inches, and in the second column you have to write down the total length of pipe. It is written, see, in feet. So diameter we have got how much? 1 inch. So write down 1 here. Okay. And total length of pipe between 1 to 2 part is 14 feet. So I have written here 14 feet. Now K factor value we have considered 5.6. So write down 5.6. Okay. Sprinkler elevation. At what height you have placed this sprinkler? So that height 12 feet I am writing here. Okay. Then pressure, estimated pressure value you will get after the calculation. Here you have to write down the sprinkler coverage area. One sprinkler can cover maximum to 25 square feet in case of light hazard. So that I have written here. Okay. Now finally, which type of fitting is coming? Open this sheet and see. From 1 to 2 part, only 90-degree elbow we have to consider. Okay. If you want to connect the last sprinkler to this, because pipe is running above the false ceiling, a sprinkler we have placed in false ceiling level. If you want to connect the pipe to this sprinkler, so 190-degree elbow will comes. Na? So here you have to write down that detail. So for in standard fitting, just hit on this drop down list. From here you have to select the 90-degree elbow. Automatically software will give you the equivalent length. Okay. Like this. Now come to next 2 to 3 part. 2 to 3 part. Here also same, pipe diameter is same, spacing between pipe length is 14 feet and 5.6 standard elevation 12 feet. Okay, you have to fill this detail. 225 maximum coverage area. And here now when you see in Excel sheet for 2 to 3 part, now you have to consider the T fitting because a sprinkler is coming between. So to connect this pipe to this sprinkler, so one T fitting, you have to drop the pipe down. So okay, here in standard fitting, just hit on this drop down list and from here select the T or cross. As per that you will get the. Okay, now open the drawing. Okay, now come to next part 3 to 8. So for 3 to 8, see diameter is 1.25 inch, pipe total length 21 feet. Okay, so here we have to fill this 3 to 8. Everything is similar, only diameter is 1.25 now and 21 feet total length. Pipe length 5.6, elevation 12 feet only, coverage area is same 225. Here now when you see in this sprinkler for 3 to 8 path, here see one T fitting and one this 90-degree elbow also we have to consider. So in a standard fitting, here in the wrist, one 90-degree elbow is coming and one T fitting. So for elbow you have to use E, capital E, write down here. In a standard fitting, write down capital E, and one T fitting is also coming, write down capital T. Hit on OK. Now see here, one elbow, one T fitting. As per that you will get the equivalent length. Now come, okay, we have covered 3 to 8 path. Now come to here. From here we are going to consider 4 to 5 path, 5 to 8. Both diameter is 1 inch, spacing is 14. So now 4 to 5 path, 4 to 5, 5 to 6. Okay. So here I am writing now 4 to 5. Okay. Next is 5 to 6. So here everything is similar. 1 inch, 14 feet total pipe length, 1 inch, 14 feet total pipe length, and 5.6. Okay. First I am talking about 4 to 5 path. So here sprinkler is at 12 feet. Write down each sprinkler coverage area 225 square feet that I have written here. Now which type of fitting is coming for only 190 degree. So now here 4 to 5 and 5 to 6 we have completed. Here in 5 to 6 path, one T-fitting will come. So you can see here 5 to 6 for one T-fitting we have to consider. Now come to 6 to 8. 6 to 8 pipe size is 1.25 and length of that pipe 5 feet. Okay, so that detail you have to fill. 6 to 8 path, 1.25 pipe size, total length 5 feet, everything is similar. Now which type of fitting will comes? One T-fitting you have to consider, okay, here. So okay, not one T-fitting, one T-fitting for this, one T-fitting is enough. So here I am writing one T-fitting, okay. Now come to next path, 8 to 9 path. Here see the pipe length is 16 feet and diameter is 2 inch. 8 to 9 path. So here I am writing 8 to 9 path, diameter 2 inch, total length 16 feet and K factor is same 5.6. Sprinkler elevation 12. Coverage area of each sprinkler. Now which type of fitting will comes? 8 to 1 T fitting, this one you have to consider, okay, only 1 T fitting. Okay, so I am writing here 8 to 9 path, 1 T fitting, where it is, okay, as per that equivalent length you will get. Now next path, just come here, from here you have to come one step below, okay. After 8 to 9 path, next is 7 to 9. Here also same, okay, diameter is 1.25, pipe length is 5 feet, 7 to 9 path. So here 7 to 9 path, diameter 1.25, total pipe length 5 and everything write down similar 5.6 K factor, elevation 12, okay, and coverage area you have to write down and which type of fitting, only 190-degree elbow we have to consider. Okay, so here I am writing elbow. Okay, next path is what? 9 to 10. So in 9 to 10 you have to consider the maximum diameter which is coming 3 inch and total length 50 plus 24. 74 total length, 3 inch diameter and fitting 1 T fitting. Here a 190-degree elbow. Okay, 74 3 inch diameter and path is what? 9 to 10. So I am writing here 9 to 10 path, diameter 3 inch, 74 total pipe length, K factor is similar. Now you have to write down the elevation, okay, what you want, elevation write down 12 feet, sprinkler coverage area and 1 T fitting, 1 elbow. So E and T, enter E and T in standard fitting, okay. Okay, now come to next 10 to 11 path. So in 10 to 11 when you see the pipe size is now 4 inch. Here some valves and is also coming like gate valve, 2 gate valve, 1 non-return valve is also coming. Total pipe length 20, 15, 35. So okay, 10 to 11 path. Here I am writing 10 to 11 path, diameter 4 inch, total length 35 feet. Okay, and don't need to fill this last because this is the last section. So the final node will be the inflow node. Okay, remember, don't need to write 5 K factor in this last column and height and everything. Here which type of fitting is coming? See, here 2 gate valve and 1 non-return valve. Okay, so this is the discharge line. So in discharge and generally we are placing non-return valve also. 2 gate valve, suppose this is a non-return valve. So okay, that you have to consider. In fitting, see 2 gate valve. So where is gate valve? For gate valve you have to use the G. So I am writing 2G and 1 check valve, non-return valve, check valve. So C. Okay, hit on okay. As per that you will get the equivalent length. Okay. Finally, the final node will be the inflow node. So where is your, here remember this, the final node will be the inflow node. Okay. So here what you have to do, select the final node, okay, whatever, wherever, just select, hit on mark inflow node. See, here you will get one arrow, okay. After doing this, now the next step, we have to do the calculation. So for calculation here, you can see one icon is given, calculation icon, just hit on that. Now see, first of all, here also in calculation tab, see the demand or supply. So first you have to check the demand, minimum residual pressure, how much we have to take for any sprinkler, 7 psi, okay, and minimum desired density is 0.1. You know that in case of light hazard, 0.1 GPM per. So that detail you have to fill here, okay. Now come to here in balance. Here see minimum nodal pressure, how much coverage to, so hit on this. See, the maximum nodal pressure imbalance in the system is not to be exceed this value before the program get a solution. So minimum I am just using here 0.0001, okay, should not be greater than 0.01. So maximum nodal pressure 0.601, okay. So just take here 5 to 6. After that, after 5 to 6, next path is what? 6 to 8, then 8 to 9, okay. 5 to 6, 6 to 8, 8 to 9, then 7 to 9, 9 to 10, okay. First save it, this one, okay, it is right. Now as I told you, hit on calculate, and here everything is similar. Just after filling this all detail, you have to press calculate from here. Now here you will get the result. Can you see? In solution, see, everything is given. Demand residual pressure at system inflow node 68.297 and demand flow at system inflow node is 32.325.226. Our main target is we have to find out this only, na, the system flow rate and what? System pressure, okay. So after that, hit on calculate, okay. After, if you want to get the report, so in report tab, here the option is given quick print report, hit on that, or you can use the shortcut also, Control P, okay. Now here in this name, Microsoft print to PDF only, select it, okay. To save, suppose in desktop with the name what? Hydraulic calculation for sprinkler, for a sprinkler system, okay. Save it in desktop, okay. Now see, the print is, if you want to open the PDF file, you can just open your desktop. In that already we have saved. See, hydraulic calculation for sprinkler. See, the restaurant sitting area, fire sprinkler report is given here. Everything you can view from here. Our main target is what? We have to view this one. Scroll down. Here you will get the overall sprinkler output data. Hydraulic most demanding sprinkler node, okay. Sprinkler summary is given here. Sprinkler flow is how much? 325.23 GPM average sprinkler flow, okay. Here see, the demand flow at system inflow node is 325.23 GPM and minimum required residual pressure system inflow node is 68 psi. So in this way, we have to do the hydraulic calculation for sprinkler system by using a Light software. Same process, same procedure you have to follow for ordinary hazard and extra hazard occupancy. I hope all of you enjoy this session. See